Hello everybody. I'm going to do a brief introduction on the topic transducers. Okay, so let us see some of the learning outcomes related to this topic. By the end of this slide, we're going to look at some of the terminologies and definitions related to transducers. We're going to look at signal conditioning and processing. We're going to learn about electrical transducers that are used for non-electrical quantities like length, displacement, velocity, acceleration, force, torque, level, pressure, temperature, flow, sound, light, humidity, and pH. We're going to look at pneumatic transducers that are used for pressures, level, temperature, and flow detection. Okay, so we're going to look at some of the terminologies and definitions related to transducers. The first point I'm going to share with you is something called an actuator. An actuator is a device that converts an electric signal to a physical output. So basically, you can take an electric bulb as an example of an actuator. So in case of an electric bulb, we're basically given electricity as input and we're receiving light as the physical output. So an electric bulb is a basic example of an actuator. The second example that you can take is an electric motor. So we're giving electricity as an input and we're getting mechanical rotation in form of output, right? So an electric motor is another example of an actuator. So the next thing we're going to look at is a transducer. A transducer is basically an electronic device that converts energy from one form to another. The process of converting energy from one form to another is known as transduction. The third thing we're going to look at is a sensor. So basically, a sensor is a device that converts a physical parameter to an electrical output. So we have seen that actuator is a device that converts an electrical signal to a physical output, right? But for a sensor, it's basically the opposite of an actuator. For the sensor, we're basically converting the physical parameter to the output in form of electrical output, right? So basically, sensor is an opposite of an actuator. Okay, so we're going to look at what a sensor is and how it generally works. So a sensor will basically take some sort of physical phenomenon as input. Let us say that physical phenomenon can be anything, right? So we can take, it can be temperature, it can be pressure, or some other thing, right? So the sensor will take this physical phenomenon and it will transform it to be outputted in form of electrical signal. So this is basically how a sensor works. What to look for in a sensor? There are a few factors that determine whether the sensor is of good quality or not. So we need to consider those factors while choosing a sensor. First thing we need to look at is the dynamic range of a sensor. So basically, the dynamic range is the minimum and maximum range of measured physical quantity, and the minimum maximum range for the electric output. So what this is trying to say is that the sensor needs to accept a wide range of input and it should be able to display a wide range of output. So that is the dynamic range of a sensor. Secondly, we need to see how the output changes with respect to the input. So that is basically the input and output relation. Third thing we need to look at is the sensitivity and resolution of a sensor. So we need to see the smallest value that can be detected by the sensor. So that is the sensitivity and resolution of sensor. The fourth thing we need to see is the power requirements of a sensor. So we need to see whether the sensor requires some sort of passive power supply or whether it needs an active power supply. The fifth thing we need to look at is the bandwidth and the frequency response of a sensor. Bandwidth, also referred to as a frequency response, is the indication of a sensor's ability to respond to changes in its measured input. So basically, it is the frequency response of a sensor. The last thing we need to see is how to calibrate the sensor, right? So there are different conditions. There will be different conditions for the sensor to be used. So for every condition, the sensor needs to be calibrated to be measured in those conditions, right? So you need to see how to calibrate the sensor for different conditions. Okay, so we're going to look at different types of transducers. So the first three transducer, as you can see, is used to measure the temperature. So the first one is the thermocouple. So thermocouple will basically accept temperature as an input, and it is excited in form of current. So basically the change in temperature will cause some sort of current, and this current will be then output as voltage by the thermocouple. So that is the thermocouple is the first transducer. Second transducer is RTD. RTD is basically short for resistance temperature detector. So this will also take temperature as an input, and the change in temperature will cause some sort of current and voltage, and this current and voltage will be output in form of resistance. So the RTD is a second example of a temperature transducer. The third transducer is called thermistor. So basically the thermistor will take temperature as input like the previous two, and this will generate some sort of current and voltage as well. So that change in current and voltage will then be outputted as in form of resistance. So these three are the examples of a temperature transducer. The second transducer we're going to look at is the strain gauge and piezoelectric transducers. So basically these two transducers accepts pressure and sound as input. So in case of a strain gauge, when the change in pressure and sound will create some sort of voltage, and that voltage will then be outputted in form of resistance by the strain gauge. So we're basically going to read this resistance, and it will tell us how much the pressure and sound is changing. The second type of transducer that's used to measure pressure and sound is the piezoelectric transducer. So like the previous one, piezoelectric transducer will take pressure and sound as input, and that pressure and sound will then generate some sort of voltage. That voltage will be outputted in form of voltage as well. So this voltage will be measured by the piezoelectric transducer and will indicate how the change in pressure and sound. The third transducer we're going to look at is the strain gauge and piezoelectric. Is the same thing. So basically in this case the strain gauge and piezoelectric transducer is used to measure force and torque. Like the previous transducers, the strain gauge will take strain gauge and piezoelectric transducer will take force and torque as an input, and that force and torque will generate some sort of voltage that voltage will then be converted and outputted in form of voltage as well. So this now we're going to measure this voltage to determine the change in force and torque. The fourth transducer is the string gauge piezoelectric transducer variable capacitance. So these three transducers are used to measure the acceleration or vibration. So like the previous one, the string gauge piezoelectric transducer, variable transducer, and capacitance transducer will take acceleration and vibration as an input, and that acceleration and vibration will cause some sort of change in voltage. That change in voltage will then be detected. The change in voltage will then be converted to voltage for this in case of strain gauge, charge in case of piezoelectric transducers, and voltage in case of the variable transducer and capacitor. So the output will be in form of voltage, charge, and voltage, right? So we will measure these three quantities in order to determine the change in acceleration and vibration. Okay, so these are some of the other types of transducers. The first one is the LVDT and RVDT transducer and the potentiometer transducer. So basically, these three transducers will take position and displacement as an input, and they will generate this position and displacement will generate some sort of voltage, and this voltage will be then converted into AC voltage and voltage respectively, and this we will basically measure the change in AC voltage and voltage to measure the change in position and displacement. The second transducer we're going to look at is the photodiode transducer. So basically, the photodiode will accept light as an input, and it will directly convert the light in form of current. So there's no it doesn't create any excitation. So it will directly convert light intensity and it convert into current. So we measure this current to measure the change, the small change in light intensity. So basically, the photodiode is used to measure the intensity of light. The third transducer is called the vortex shedding transducer and the turbine transducer. So these two transducers will accept it's used to measure the flow rate. So it will take this flow rate as input. It will generate some voltage, and that voltage will be then converted in form of pulse and frequency. This pulse or frequency is measured and it is used to determine the flow rate of any liquid or liquids. So basically, the vortex shedding and turbine is used to measure the flow rate. The last transducer we're going to look at is the electrode. So the electrode is basically used to measure the pH. So it will directly take pH as an input. pH of a solution will be taken as input, and it will be directly converted to voltage. This voltage will then be measured to determine the pH of a solution. So electrode transducer is used to measure the pH of a solution. Okay, so now we're going to look at something called signal conditioners. So signal conditioners are basically devices or equipment that are employed to modify the characteristics of a signal. So the first type of signal conditioner is called the analog to digital conversion. This ADC is used for the quantization of a continuous signal. Quantization in mathematics and digital signal processing is the process of mapping input values from a large set, often a continuous set, to output values in a smaller set, often with a finite number of elements. So, ADC is used for the quantization of a continuous signal. Another type of signal conditioners is the amplification. So the amplification is used to increase the signal level. The third type of signal conditioner is called attenuation. Attenuation decreases the signal level. The fourth type is the bridge circuit. The bridge circuit is used to increase the resistance output of a signal. The fifth type of signal conditioner is called a charge amplification. This charge amplification will convert charge to voltage. So these are the other types of signal conditioners. The first one is the co-junction compensation. It provides temperature correction for thermocouple connection points. So it is a technique that is used in temperature measurement systems to compensate for the ambient temperature at the point where the thermocouple wires are connected to the measuring instruments. So the temperature at this point is known as the co-junction temperature, and it can affect the accuracy of a temperature measurement. The second signal conditioner is the digital to analog conversion. This converts discrete signals to continuous signals. It is a process of converting, like I said, it is used to convert digital signal into analog signal. This process is commonly used in applications such as audio and video processing, where digital signals needs to be converted into analog signals for playback on speakers or displays. The third type of signal conditioners is the excitation. Excitation is the process of providing an input signal to a system or device in order to generate a response. In context of measurement, excitation is often used to simulate a sensor or transducer to produce a measurable output. The fourth type of signal conditioner is the filter. Filter is basically a device or process used to remove unwanted noise or interference from signals. Filters can be analog or digital, and they can be designed to remove specific frequencies of or types of noises. The next type of signal conditioners is called isolation, and isolation of signal is the technique used to prevent unwanted electrical connections between different parts of a system or between different systems. Isolation can be achieved through the use of optocouplers, transformers, or other isolation devices. The next signal conditioner is called linearization. In linearization of a signal, it is basically a process used to convert a non-linear signal into a linear signal. This can be important in applications such as control systems, where linear signals are easier to work with than non-linear signals. The last signal conditioner is called multiplexing, and in multiplexing, it is a technique that is used to transmit multiple signals over a single channel or medium. Multiplexing can be achieved through techniques such as time division multiplexing or TDM, or frequency division multiplexing, also known as FDM. Overall, These signal conditioners are important for signal processing and measurement, and understanding them can be helpful in designing and implementing measurement and control systems. So this is the summary of signal conditioners. Okay, so the next thing we're going to look at is the characteristics and the choice of transducers. So this is the general schematic of the characteristics of transducers. The first characteristics is the input characteristics, and under input characteristics, we are going to look at the type of input. We're going to look at the operating range of our transducers, and we're going to look at the loading effect of transducers. The second characteristics is the output characteristics, and under output characteristics, we're going to look at the type of electrical output. We're going to look at output range, and we're going to look at output impedance.